Hello everyone and welcome to today's episode on this little channel. In today's tutorial, we want to look at this particular question on the board, and this question falls under selecting from a bag with replacement or drawing from a box of bag with replacement. So when we talk about selecting from a bag or box with replacement, it simply means that you have a bag and this bag contains, let's say, 5 marbles, and then you have to pick a marble from the bag one after the other. You have to pick 2 marbles from this bag, one after the other. And then once you are done, you are going to replace it back. So let's take it that on the first pick, we pick this marble. And then once we are done with it, we substitute it back. So initially, we are having 5 marbles. And then after the first draw, we replace it back. So the number of marbles in the bag are still the same, which is 5. So the result from the second draw will not depend on the first marble that draw. It will not depend on that because the marble was replaced back and the number of marbles in the bag are still intact. So we want to look at question of this very form. So we have our first question. A bag contains 10 balls that differ only in color. 4 are green and then 6 are red. 2 marbles are drawn from the bag with replacement. We want to find the probability that both are red, both are green, both have the same color, and then both are of different color. Now, what this question is saying is that we have a bag, a very nice bag, and then this bag contains 10 balls. So this is our bag, and then it contains 10 balls, of which 4 are green. So we have 1, 2, 3, 4, and then 6 are red. So in whole, how many marbles do we have in the bag? We have 10 marbles or 10 balls in the bag. Now I want to pick 2 marbles from this bag with replacement. It means that we are going to pick the first one from the bag and then we will place it back. So let's say we are picking this marble from the bag, and once we are done with it, we will place it back. So once we place it back, the number of marbles in the bag will still be the same. Then we pick another marble from the bag. Let's say this marble from the bag, and then we are going to replace it back. So once we are done with whatever we want to do with it, we replace it back. So the number of marbles in the bag will still be the same. So we are saying that if 2 marbles are drawn from the bag with replacement, what is the probability that both of the marbles are red? So both of the marbles being red means that on the first pick, we are going to get a red marble, and then on the second pick, we are also going to get a red marble. So we have the first being red and the second being red. So let's use J for green color. Let's use G for green color, and then R for red color ball from the bag. So we are using R for red, and then G for what? Green ball. So we have number of red marbles in the bag. We have 6, and then number of green marbles or green balls in the bag, we have 4. And then our number of marbles in the bag, that is the sample space, we have 10. Before we look at both of them being red, let's find the probability of picking a red marble from the bag and then a green marble from the bag. So we have the probability of picking red marble from the bag is number of red marbles in the bag all over the total of marbles in the bag. How many red marbles do we have in the bag? We have 1, 2, 3, 4, 5, 6. So we have 6 all over the total marbles in the back, that is 10. And then we have probability of picking a green marble from the back, number of green marbles in the back, all over the total marbles in the back. So we have 1, 2, 3, 4, all over what? 10. Now once you know the probability of picking a green marble from the back and then red marble from the back, let's proceed to find the probability of picking a marble from the back or a ball from the back of which both are red. So both of them being red means that the first marble that we are picking is red. So the first is red and the second marble is also red. The first pick we had a red and on the second pick too we have a red. Since we are having the intersection, we are going to apply the multiplication law. So we are going to have probability that the first pick is red multiplied by the probability that on the second pick too we are having what? A red color. So once you just have to plug in their respective probabilities. We have red, probability of picking a red marble is what? 6 all over 10. And then the same red marble, probability of picking a red marble is still 6 over 10. So you just have to multiply. We have 36 all over 100. You can convert it to decimal to give you 0.36, or you can leave it as that. Any one of them will still be marked correct. So let's look at probability that both are green. So both are green means that on the first pick we are getting a green marble and the second pick too we are getting a green marble. So we have the probability that the first pick or the first marble or ball that we are drawing from the back is a green marble and the second marble that we are drawing is also a green marble. Very, very easy. The first marble that we are picking is a green and the second marble is also a green, and that is going to give us both of them being green. Since we are having the intersection, we can split it and write it as a probability that the first is green multiplied by the probability that the second is also green. So probability of picking a green marble, we have 4 all over 10 multiplied by probability of picking the same green marble, we have what? 4 over 10. And this is giving us 16 all over what? 100. You can still convert it to decimal or leave your answer in this form. Very, very easy. Now let's look at probability that both are of the same color. Both are of the same color. Now probability that both are of the same color means that on the first pick we are getting a red marble and the second pick we are getting a red marble. Or on the first pick we can get a green marble and the second pick we also get a green marble. So this is how we are going to write it. Probability that on the first pick we are getting a red marble and on the second pick we are getting a red marble. Or the probability that on the first pick we are getting a green marble and on the second pick we are also getting a green marble. And this is giving us both of them being the same color. Since we are having two colors, this is what we are going to have. The first is giving us red and the second is giving us red, and this is giving us the same color. Or we can have green and then green. So we can write it as probability that the first is red multiplied by the probability that the second is also red. Now all in probability means the addition, so we have plus. Now once we have this, we just have to plug in their respective probabilities. So the first one green and then the first one red and then the second one red. We have red and red, and that gives us what? 36 all over 100. we have plus, and then first green, second green, first green, second green, we have 16 all over 100. Now this is just addition. Since the denominators are the same, we are going to pick 1. Then we add the numerator, so we have 52. So the probability that both are the same color is 52 out of 100. Let's look at the last one. Both are of different colors. So both are of different colors means that on the first marble pick or on the first draw, we are getting a green marble, and then the second pick we are getting a red marble. So you can see that we have different colors. Or on the first pick we can get a green, and then on the second pick we can get a red. So we have different colors. So we have probability that on the first pick we are getting a red marble, and on the second pick we are getting a green marble. So you can see that with this event we have different colors. Or it can happen that on the first pick we will get a green marble, and on the second pick we will get what? A red marble. Very, very easy. In each of these instances we have different colors and then different colors. So we have probability that the first one is red multiplied by probability that the second one is green. The all means addition, and then on the first pick we have a green multiplied by, so we just have to substitute in their respective probabilities. So we are going to have red, we have 6 all over 10, green we have 4 all over 10, then we have plus green we have 4 over 10, and then red we have 6 all over 10. So this is going to give us 24 all over 100 plus 24 all over 100, and this is going to give us 48 all over 100. So the probability that they are of different colors is 48 all over 100. You can convert it to decimal to get 0.48. Very, very easy. This brings us to the end of today's lesson. See you tomorrow. Bye bye.